Hello and welcome. Generative AI with pre-trained LLMs, that is large language models. The goal here being to get some practice in using state-of-the-art LLMs via the Hugging Face Transformers library. I'm going to go ahead and use Mistral 7B with this one. Um, well, we already decided on that. And we're also going to be doing some text generation today. We're going to be making some poems. um, I already have the Juypter Lab notebook all set up and have done everything because this one did take several minutes for everything to go through. I even had to restart my computer at one point. We'll get into that. Um, we are going to be running 3 test cases using one key generation parameter. The parameter I chose is temperature to control the randomness of the text output as opposed to controlling the output length or controlling the token selection diversity. After that, we'll analyze how the results of it um, and then get you home in time for dinner. Alrighty, let's go. Um, yeah, I already ran it. Normally I'd be like, look at this, click, click, isn't this exciting? But like this takes way too long. So the first thing we're gonna do is use the Hugging Face Transformers library with PyTorch as backend and other core libraries, as well as Akira's library. We needed that. And this one was a doozy, I gotta tell you, but it's up and running. So we do the pip install here, and we're using the Jupyter because I'm just new to it, but whatever, it's kind of cool, I guess. Um, and this is the notebook. I might try the lab after this one, but this is kind of like so that other people can see my work too. Good learning experience. Anyway, so once all those are installed, then we're going to go ahead and run this command here, import the OS. That was kind of because of an issue with the Keras compatibility. Now, next thing we're going to do is import the PyTorch as well as the time library and a couple other things like pipelines, bytes and bits, auto tokenizer, and to kind of talk about that. The auto class automatically detects the specific architecture of the Mistral model and loads the correct corresponding PyTorch or TensorFlow or what have you. And the auto tokenizer is the translator, which handles the essential processes of converting the human readable text into numerical data or tokens that the model can understand, converting the model's numeric output then back into readable text. The tokenizer breaks data down into numbers and assigns a unique ID for each piece, and then it stitches those back together to form the final output. Um, the auto tokenizer automatically detects the specific tokenizer associated with the Mistral model, um, which might use techniques like the byte pair, excuse me, encoding or sentence piece to load the correct version. And of course, time is just a standard library for time-related tasks, which we will use to, monitor how quick our model's running. And the pipeline is a high-level wrapper that's often we ended up needing it. So we ran that command, gives us a warning, but that's okay. I think it's like a depreciation thing. Yeah. And then the next thing we're going to do is define the model and configure it for quantization. Um, so the cell below sets up the device quantization and loads the Mistral 7B, and it's called 7B because it has 7 billion parameters. So here you have the model ID, the device, if it's available, otherwise CPU. In this case, I think I did have to use CPU. Um, we got a little print statement to make sure we're not just staring into space forever. Um, next, after that, this confirms that the tokenizer did load successfully. And like I said, that's just to kind of break it down and from, you know, characters and text as we see it in a numeric value because computers kind of can't read like we can. Um, after that, did I just show you that? Yeah, this loads the model and the tokenizer, and that did take quite a while. Uh, the next will kind of define the prompt on the generation. I had to do a lot of kind of like stitching on this one, so normally my notebooks are a little bit cleaner, but this was a doozy. So here we're defining the prompt, and like I said, it's text generation. So we're going to write a short, suspenseful story about an antique clock collector who finds a cryptid message hidden inside a newly acquired timepiece from the 1980s, and the message must hint at a long lost treasure. I originally went with like 256 characters each generation and had to drop it to 80 just because I was like, this is taking a while. I probably could have done 256, but and it does cut off, interestingly enough. So we have this going on here. The def generate story pipeline includes temperature as a float, and the max length, like I said, int 80. Um, you have the messages here, feeds it into the tokenizer. We have the time function being called from that library we imported. Um, and then this is our output structure. And of course, the return statement. Here are the parameters that we're going to be monitoring. The temperature, like I had mentioned. Um, oh my gosh, I'm already at 6 minutes. So this just displays the results in the format we want. This took quite a while. One, two, three. Don't make fun of my PC. Yeah, they're the times though. And with the different temperatures, they took different times. So we have 3 different stories though, as you can see, and it tells you the time based on the library, and the temperature as well, based on the statements and the structure there. Now to explain this, the goal here is to determine how the temperature influences the model's output quality. That's why we bothered to insert that. Temperature controls the randomness of the token selection as mentioned earlier. The lower the temperature, the higher probability for less random, more predictable, safer, coherent text. And the higher temperature has a low probability, a high random, uh, low probability meaning you're not likely to, you know, send in your prompt and then know what's going to come back. A high random score, and it's more creative, but also more unpredictable. And next, we'll compare the stories a little bit. So at the low temperature, the highly structured, predictable one, it took the longest, and it's best for sort of like a formal summary, that sort of thing, or a factual answer. The one in the middle is kind of like a, Goldilocks situation there, not too hot, not too cold. And it's best for kind of creative writing, general purpose, where you want some level of like, you know, pizzazz, but not too much. And then the high temperature is mainly for kind of like poetry and like free flow and brainstorming and that kind of thing. Um, and that has been generative AI with pre-trained LLMs via the Hugging Face Transformers library. Just going through my steps here. It doesn't look like I've missed anything, and I do have a repository if you want to check out the Juypter Notebook or the README, which contains the data. And thanks so much. Bye.